Hey everyone! In this video, I would like to talk about logarithmic differentiation. So this is a process that involves taking the natural log of both sides of an equation and then using the properties of logarithms to help us simplify the equation and make it easier to find the derivative. This also involves using implicit differentiation a little bit. So I want to talk through an example, take a look at the process and how to do this, and hopefully this all makes sense. So in my example, I have y is equal to x squared times the square root of 5x plus 1. And this is all divided by 3x minus 2, and that quantity is cubed. So taking a look at this, just initially, if I were to try to find the derivative of this equation, it would be very complicated. I would need a combination of the chain rule, along with the product rule, the quotient rule, some more chain rule, and it's going to get very messy. But we can use our properties of logarithms to make this a little bit more manageable. So that's what logarithmic differentiation is. So what we're going to do, the first step is we're going to take the natural log of both sides. So on the left, you have the natural log of y, and then on the right-hand side, we have the natural log of all of this stuff. Once we take the natural log of both sides, on the right-hand side, now we can use our properties of logarithms to expand this equation, which will make it easier to find the derivative. So on the left-hand side, we still have our natural log. And now expanding this on the right-hand side, wherever there's multiplication, we can use our product rule for logarithms. And then there is the one piece of division, so that's going to be the quotient rule. So we get the natural log of x squared, and now product rule plus the natural log of the square root. And then our quotient rule, we're going to subtract the natural log of 3x minus 2 quantity cubed. And now the last step, we can use our power rule to finish expanding. So in our first term, this exponent of 2, we'll bring that down out front. So 2 times the natural log of x. Our middle term, remember the square root, we can rewrite that as the 1/2 power. So that's going to be 1/2 times the natural log of 5x plus 1. And then in this last term, we'll bring the 3 down out front as well. Okay, so now that we are fully expanded, we can take the derivative of each term in here. On the left-hand side of this equation, we do have the term the natural log of y. And because of that term, we actually need to use implicit differentiation on this entire equation. So we are going to take the derivative of the natural log of y with respect to x. And if we do that, we're going to end up with 1 over y times dy over dx. Now, dy over dx, that's our notation for a derivative, but I'm actually going to just rewrite that. So instead of writing dy over dx, it's the same if I write y prime. Now on the right-hand side, everything here is in terms of x. So we can go through and we can find the derivative of all this. So our first term, we have 2 times the derivative of the natural log of x. So that's going to be 2 times 1 over x. In the middle, we have our 1/2 out front. The derivative of the natural log is 1 over whatever is on the inside. And then using our chain rule, we need to multiply by the derivative of the inside, which is 5. And then we have minus 3, and doing the same thing, the derivative of the natural log, 1 over 3x minus 2, times the derivative of the inside, which is 3. All right, so let's move up here. So now I have y prime over y. So remember that y prime, that means the exact same thing as dy over dx. And then the other side, we have 2 over x. And then let's simplify these other terms. So in the middle, I'm going to have a 5 in the numerator. And then in the denominator, I'm going to take that 2 and I'm going to distribute that to both parts. So that's going to give me 10x plus 2. And then our last term, we have 3 times 3 in the numerator, so that's minus 9 over 3x minus 2. I want to isolate y prime, So I'm going to multiply both sides by y. So your y prime is equal to y times all of this stuff. Okay. And now the last step in this process of logarithmic differentiation, we used implicit differentiation to help us find the derivative. We only needed it for one term, the natural log of y, but we still had to use that. Now, our original equation was not defined implicitly. So that means we don't want our derivative to be written in terms of x and y. We only want it to be written in terms of x. So taking a look at what we have y prime is equal to y times all of that. Well, I want to get rid of that y. So what we actually need to do is a little bit of substitution. Going back to our very original equation we were given, we know what y is in terms of x. So we just need to substitute that in. So y prime, substituting that in, let's see, we have this big fraction, x squared times the square root over 3x minus 2 cubed, and then we'll multiply that by all of this other stuff from the derivative that we found. Okay, so here's our derivative. And just to summarize this process and how we do this, we take the natural log of both sides. We use the properties of logarithms to expand our equation as much as possible. After we expand, we use implicit differentiation to find the derivative. We're going to isolate the dy over dx, or as I showed here, the y prime. And then the last step is we need to back substitute. We'll plug in our original equation for y, and that gives us our derivative.